Good day, everyone. So, welcome back to the third episode. Now, we want to talk about the theory of what? Of magnetism. We want to talk about the theory of magnetism. So now, if I cut a bar magnet, so the one I said I'm going to explain next. So if I cut a bar magnet, let's say I have a magnet like this now. So let's say the magnet, as I said, magnet has two poles, the north and the south pole. And the magnetic flux, please write it down, very important, a cogent point. If I have a magnet, now the magnetic flux of a magnet will always flow, will always move in the direction from north to south. It will always move from north to south, the direction. It will always move from what? From north to south. And they must not cross. Please, what I did now is very wrong. They must not what? Cross. So that's property of magnet. They must not cross. So, but it moves in what direction? From where? From north to south. That is outside the magnet. But inside the magnet, it moves from south to north. Get it right and don't get it wrong. What did I say? Outside the magnet that we can see like this, it moves from where to where? The magnetic flux move from where? North to south. That is outside. We can see. But inside the magnet, it will move from south to north. And make sure that this line, they do not cross. So that's the property of what? Magnetic flux line. They do not cross. So that's why I said what I did the other time. The lines must not cross and they are hemispherical. So now this is what I want to explain. Let's say I cut this magnet. I want to cut it in 3 places. And we are going to get the polarity of everything. Very simple to get. So let's say I have this place, XX. I cut it in XX. So let's say I cut it here. So let me call it YY. So after cutting it, you know this is what I'm going to have. I'm going to have this. So this is XX. And we have north here, you remember. So if I cut it here, I'm going to have this. So I'm going to have this. So if I cut it here too, I'm going to have this. So this place is YY. You get it at all. So this place is YY. So this is YY. So I want to cut it at this point, YY. So this is XX. Do you get it now? So you can be asked the polarity of this. So let's say they now put P, Q, R, S. Okay, don't let me use S. P, Q, R, M. P, Q, R, M. And we have S here. Okay, don't let me put it here. So let me just put it. Let me put it here. So let me put P. You know, they will give you this. So they will not tell you that if it is cut in this section, if it is section at XX and YY, so they will not put letters here, P, Q, R, M. They will not ask for the polarity at P, Q, R, and M. Like, will it be north, south, north, and the likes. So we want to get the polarity. So after cutting in this section XX, if I section it at this point, XX now, if I cut it at that point, you know, I told you that whenever we have a piece of magnet, it's going to retain the property. So this is north now. Automatically, this place will be south. Do you get it at all? Automatically, this place will be south. And how do I know the polarity of this place? This and this, they must not form consequent poles. What do I mean by consequent poles? Consequent poles are poles that are the same. Consequent poles means consequent poles can be south or north. And if you have consequent poles, they will not cancel out. So we must have magnetic neutrality. So if this place is south, automatically this place will be north. So that after cutting it, they will have magnetic neutrality. What do I call it? Magnetic neutrality. So because if it is south, it will not cancel out. But not as south, opposite, so it will cancel out. So this one now, since this is a magnet now, this is also a magnet. This magnet 1, magnet 2, magnet 3. This is another magnet. And if this place is north, magnet must have 2 poles. If this place is north, then this place will be what? South. You remember, there must be magnetic neutrality. So if this place is south, this place must be what? North. Can you see that each and every one of them has what? Two poles, which is what? A magnet. So north south, and north south. So they can actually change the orientation or put it anyhow. So you have to just be very careful. So that's the how to know the what. Whenever any magnet is being sectioned, so that is the how to know the polarity. So in short now, what's our P? Our P is what? S. Our Q is what? N. Our R is what? S. And our M is what? North. So that's Sn, Sn. So that's the theory of magnet. Now we now have three things. Well, so we have diamagnetic. We have three types of magnets. We have diamagnetic, we have paramagnetic, and we have what? Ferromagnetic. This ferromagnetic is divided into two. It's divided into the soft iron and the what? It's divided into soft iron and steel. But very good, I've explained soft iron and steel in the last episode. So what is diamagnetic? Diamagnetic. So what is diamagnetic? So diamagnetic, write it down now. Diamagnetic are materials that set their longer axis. Diamagnetic are material that set their longer axis. I want to explain diamagnetic now. Diamagnetic, they set their what? Longer axis. Perpendicular, they set their longer axis. Perpendicular to where? Diamagnetic are material that they set their longer axis perpendicular to the direction of strong magnetic field. To the direction of what? Strong magnetic field. So what you just need to take note under diamagnetic is that what? They are perpendicular. They may not use the word perpendicular. They can also use what? Right angle. You should agree with me that right angle is 90 and perpendicular also means what? 90. Why paramagnetic? Paramagnetic. Para starts with what? So paramagnetic, parallel. So paramagnetic, parallel. So paramagnetic in short are material that set same thing. Just that para is parallel. Para is what? Parallel. While diamagnetic is perpendicular or at angle 90 or at right angle. So this is angle 90 degree. So if I want to divide paramagnetic, so I will say these are what? Material that set their longer axis. They set their longer axis where? Parallel. So they set their longer axis parallel to the direction of the strong magnetic field. Do you get it at all? So that's the difference between diamagnetic and paramagnetic. Another difference is that paramagnetic has positive susceptibility. Paramagnetic, it has positive susceptibility. Positive what? Susceptibility. It has positive susceptibility. We have susceptibility and we have permeability. So we'll be talking about susceptibility here. It has positive susceptibility and this one has negative susceptibility. Negative susceptibility. So this one has positive susceptibility which is greater than 1. And it is greater than that of vacuum too. Why this one has negative susceptibility? So that's for diamagnetic and paramagnetic. So now we have method of magnetization. Now follow me now. We have method of magnetization and we have method of demagnetization. Under the method of magnetization, how do we magnetize? Magnetization is the process of making a magnetic material a magnet. Let me say that again. You remember in the first episode, or was it the second one, that I talked about magnetic material and non-magnetic material. What did I call magnetic material? These are material that can be made into magnets. So if I want to make them into magnets, I told you that we'll make them through which process? Magnetization. If I want to do that, we can go through the following. Number one, we can say what? Hammering. We can hammer it. Hammering in the what? In the north-south direction. Hammering in the what? In the north-south direction. Number two is that what? We should use what? Single stroke. We should use what? Single stroke. Please, this single stroke is very important. We also have double stroke too. So we can call it single stroke or single touch. What do I mean by that? Let's say I have a magnet now. I have north and south. I want to make this, I have a bar magnet. So let's say I have steel. Let's call it steel now. And I want to make this thing to be magnetic. I will bring a bar magnet. So this is steel, and let's say this is a bar magnet. So it depends on the direction of the bar magnet. Let's say the bar magnet I'm bringing, we have the south here. So if I want to what? Stroke this thing, single stroke, it's because I'm bringing one bar magnet. That's why it is single stroke. If I'm bringing two, it will be double stroke. So I'll be doing it like this. You can do like that too. So you'll be doing it like this. You'll be using that bar magnet. You'll be doing it like this. You know, I'm starting from here. Since I'm starting from here, I'm dragging it backward. I'm starting from here. So this place will be the south. We are starting from here, so it will be the south, and this place will automatically be the what? North. So if I have another bar magnet now, a steel. Okay, let's say I have a steel now, and I have this bar magnet. So let's say this place is north. Okay, let's say this place is south. So you know, I will be stroking it like this. I will be stroking it like this, like this. I will be stroking it like this. So I'm starting from here. Automatically, this place will be what? South, and this place will be what? North. But if it is double stroke, so this will be double stroke. So double stroke will come like this. These are two bar magnets. So this will still be a steel. It is not necessarily like it is steel. Oh. It can be any magnetic material. So, but these are two bar magnets. So if I have south here now, it means this place will be what? North. So this place will be north. This place will be north. And we are going to have south here. Consequent poles. Consequent poles here. Do you get it now? So, but if I have north here, then I'm going to have north, south, and what? South here. You get it now? It depends on how they orientate it. So we can have single stroke, we can have what? Double stroke. We can have single stroke, we can have double stroke or double touch. We can use what? Solenoid method. We call it solenoid or what? Electrical method. So we can use electrical method or solenoid method. What do we do in electrical method? We are going to connect it to what? To DC. If you want to magnetize, you connect the solenoid. You connect the solenoid to what? To DC supply. You connect the solenoid to what? To DC supply. You get that up. So that's it. We still have more, but these are the what? The major ones. For demagnetization now, which is the last thing we'll be talking about. For demagnetization, it is just the opposite. So number one is hammering. So we hammer in the what? In the east-west direction. So to demagnetize means we want to remove the magnetic property of a material. So we are going to hammer it in the east-west direction. Number two is that what? We do rough handling. When we rough handle it, it's going to demagnetize. So we can also what? Do eating. We can eat it. So eating, Heating, eating or rough handling it. So if you rough handling, eating. So it is going to make it to demagnetize. Or hammering, you can see if you want to magnetize, you hammer in the north-south direction. But if you want to demagnetize, you hammer in the east-west direction. Another thing is that what? Instead of you to use solenoid or electrical method with DC supply to demagnetize, then you use solenoid. You connect the solenoid with what? With AC supply. With what? With AC supply. What is AC? What is DC? AC is what? Alternating current. DC is what? Direct current. AC is alternating current. DC is direct current. And whenever we use solenoid method, we call it what? Electrical method. We call it what? Electrical method. Do you get it now? So that is all for now. Thank you for listening.